Hello, my dear friends. How are you all? I hope you all are fine. So, you are very welcome in a lecture number 1 of statistics. Okay, I hope, my dear friend, you will enjoy this lecture. So, let's start without wasting the time. So, now today we are going to discuss introduction of statistics. What is? Yes, introduction of statistics. So, basically, what is statistics? So, statistics is the study of the collection or analysis or interpretation, presentation, and organization of data. Organization of data. Okay. In other words, it is the mathematical discipline to collect and summarize the data. Okay. So, in this lecture, in this chapter, we are going to discuss about lot of data. Okay, I hope you get this point. Okay, so basically here we are going to study the manipulation of data. Okay, now let's see some examples related to statistics. Okay, so here is, now we can use to find the mean of the data. Okay, so to find the mean of the marks obtained by each student in the class whose strength is 50. Okay, so the average value here is the statistics of the marks obtained. Okay, and suppose you need to find how many numbers are employed in a city. Okay, since the city is populated with 15 lakhs people. Okay, hence we will take a survey here for 1000 people. This is that sample. Based on that, we will create the data. Which is what? Which is the statistics. Okay, I hope, my dear friend, you understand these things. So now the basics of statistics include the measure of central tendency and the measure of dispersion. Okay, the central tendency are what? They are mean, median, mode, and dispersions comprise like variance and standard deviations. Okay, so in this chapter we will discuss just only central tendencies like mean, mode, and median. Okay, and the dispersion comprises like variance and standard deviation. You will learn in the next class. Okay, you will learn in next class. I hope you get this point. Yes, now here is, let's see, central tendency. Now what is mean? Mean is the average of the observation. Mean is what? Mean is the average of the observation, and median is the central value when observations are arranged in order, like it may be arranged in ascending order or it may be arranged in descending order. Okay, so median is what? Median is the central value. Okay, now mod determines the most frequent observations in a data set. Okay, we will discuss mean, median, and mod later. Okay, yeah. So now first of all, let's see the presentation of data. Okay, now what is data? Here you can see facts or figures, numerical or otherwise, collected for a definite purpose. Okay, is called as data. Okay, got it? Now if the data collected first hand data, so that is called primary data. Okay, and if data collected from a source that already had data stored, then we can say that this is secondary data. Okay, so we have two types of data, primary data and secondary data. Got it? Yes, so now let's talk about the frequency. Now what is frequency? The number of times a particular instance occurs is called the frequency in statistics. It's called what? Frequency in statistics. Okay, so if you see the example like here is, Now if 4 students have scored the marks between 90 and 100, so here is if 4 students have scored the marks between 90 and 100, then the marks scored between 90 and 100 have a frequency of 4, okay. So we can write then the marks scored between 90 and 100 have a frequency of 4, okay. I hope you get this point. Yes, so the next here is, yes, so now let's talk about the ungrouped data. Now what is ungrouped data? So here you can see ungrouped data is data in its original or raw form, okay, and the observations are not classified in groups. Okay, you can understand it by by the example, like let's suppose we have an example: the ages of everyone present in a classroom of kindergarten kids, okay, with the teachers is as follows. Like you can see here is the age is like 3 3 4 3 5 6 3 3 4 3 3 3 3 4 3 2 27. Okay, so these are the ages of kids, okay, and this is the age of, yes, teacher. I hope you get this point. So this data shows that there is one grown-up person present in this class, and that is the teacher. So ungrouped data is easy to work when the data set is small. You can see that here is the data set is what? This is small. So this is easy to understand this data. Now if the data is large, okay, then we have to group it. Okay, so this is called the grouped data. In grouped data, observations are organized in groups. Okay, now if you talk about the examples, a class of students got different marks in a school exam. Okay, and the data is tabulated as you can see here is. So here is what marks interval, and here is number of students. It means there are 13 students for marks 0 to 20. There are 9 students for marks 21 to 40. There are 36 students for marks 41 to 60. Okay, and there are 32 students which having the marks between 61 to 80, and there are 10 students which having the marks between 81 to 100. Okay, so this is what, yeah, this is the group data. I hope you understand these things, my dear friends. Yes, so now here is, now let's see class interval. Now what is class interval? The size of the class into which a particular data is divided. Here you can see that this group, in this group data, this is the class interval. Okay, and here you can see this 20 is upper limit, okay, and this 0 is lower limit. Okay, lower limit. Got it? Understand? Now what is class width? Class width is upper class limit minus lower class limit. Okay, understand? Let's suppose, for example, consider a class interval. Consider a class interval Okay, like 31 to 40. Okay, so here we can say that here the lower class limit is 31. Okay, we can say lower class limit is 31. Okay, and the upper class limit is 40, and the class limit upper class limit is 40. Okay, so if we want to find the size or width of the class, then we can easily find. So here is, we can say that class width is equal, so we know that this is upper class limit minus lower class limit, so we can write it as 40 minus 31, and this is equals to 9. What is this? Is equals to 9. I hope you understand these things. Now let's move on. Now let's see the regular and irregular class interval. Okay, regular class interval, if we see that when the class intervals are equal or of the same sizes, here you can see the class interval are 0 to 10, 10 to 20, 20 to 30. Here if you see the width of these intervals, this is the width is what? 10 minus 0 is 10, 20 minus 10 is 10, 30 minus 20 is 10. It means the class size or class width are same in all the class intervals. Okay, so these type of intervals are regular class interval. What is? Yes, regular class interval. Now if we talk about the irregular class interval, so here is when the class intervals are of varying sizes. Okay, you can see here is 35 minus 0 is 35. 45 minus 35 is 10. 55 minus 45 is 10. Okay, so here you can see that the class sizes are varying. Okay, so these type of intervals are called, here you can see these types of intervals are irregular class interval. What is? Yes, irregular class interval. I hope you understand these things. Yes, so now what is frequency table? A frequency table or distribution shows the occurrence of a particular variable in a tabular form. Okay, when the table or distributions, when the table shows the occurrence of particular variables, okay, in the tabular form, this type of tables is called frequency table. Okay, now what is sorting? So here is raw data needs to be sorted in order to carry out operations. Okay, sorting like it may be in ascending order or it may be in descending order. So we have to sort or we have to arrange the data in descending order or in ascending order. Okay, yeah, so now let's solve some problems. So here you can see, now the question number 1 is, now blood groups of 30 students of class 8 are recorded as follows. Here this is what, this is the blood group of 30 students of class 8. Okay, like A, B, O, A, B, O, A, O, B, A, O, B, A, O, O. Okay, like this, similar like this. Okay, so represent this data in the form of frequency distribution table. Okay, frequency distribution table, and we have to identify which is most common and which is the rarest, and blood groups among these students. I hope you understand these things. Now let us show the table. So here is, this is the blood group A, B, O, A, B. Okay, and here we are going to tally, means here is, now first of all we have to see how many A are there here. Okay, so here is 1, 2, 3, okay, 4, 5, 6, 7, 8, 9. So how many? There are 9 A blood groups. Okay, so here now tally means now here is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is the meaning of 9. Okay, here we have to draw 9 lines in which after every 4 lines, okay, after every 4 lines we have to cut the 4 lines in the next one. Okay, like here is, if let's suppose this is 10, okay, so for the 10 we have to cut these 4 lines. Okay, so this is the tally. Okay, so how many? So there are 9. Okay, now let's see how many bees are there. So here is 1, 2, 3 and 4 and 5 and the last is 6. So now let's do. So here you can see 1, 2, 3, 4, 5 and 6. Okay, so there are 6 bees. Now let's find how many O's. So here identify the O's. So here 1, 2, 3, okay, and 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. How many? There are 12 O's. So here we can write it like 1, 2, 3, 4, 5. Okay, 5, 6, 7, 8, 9, 10 and 11 and 12. Okay, so this is the method to write the tally. Okay, so here is, this is what? This is 12. Now let's see A, B. Okay, now let's see A, B. So here is A, B is 1 and 2 and 3. So there are 3 ABs. Okay, so here is, you can write 1, 2, 3. So there are 3 AB. Now we have to cross check. Okay, there are total 30 students. How many students? There are total 30 students. If the sum of these numbers, if the sum of these numbers is 30, then we can say that our table is correct. Okay, got it? Now 9 plus 6 is what? This is 15. 15 plus 12, this is 27, and 27 plus 3 is 30. So the total is what? Total is 30. Okay, so we can say that our frequency table is correct. Okay, frequency distribution table is what? This is correct frequency distribution table. Now we have to find the most common blood group. So what is the most common blood group? So here you can see in the table, in O there are total 12 students, means there are total 12 such students which having the blood group O. So we can say that O is the most common blood group. So we can write most common blood group, most common blood group is equals to blood group with maximum number of students. Blood group with maximum number of students. Okay, so this is what? This is O blood group. This is O. Okay, so we can write this is O. Now rarest blood group is what? Here you can see blood group with minimum number of students means like AB. Here is there are just only 3 students which having the blood group AB. So here we can write rarest blood group. Okay, rarest blood group. This is equals to blood group blood group with a minimum number of students. Okay, number of students. So the answer is what? Answer is A, B. Answer is A, B. So the rarest blood group is A, B. Okay. Yeah. So now let's move on. So here is, so the next question is the distance in kilometer of 40 engineers from their residence to their place of work were found as follows. Okay, so this is what? This is distance in kilometer, like 5, 3, 10, 20, 25, 11, 13, 7, 12, 31, and so on. So these are the distance in kilometer of 40 engineers. Okay, so these are the distance in kilometer of 40 engineers from their residence to their place of work. Now construct a grouped frequency. Now here is, we have to construct a grouped frequency distribution table. Okay, with class size 5 for the data. For the data given above, taking the first interval as 0 to 5, and here 5 not included. Okay, now what main features do you observe from this tabular representation? Got it? Yes. Yes. So now let's draw the table. So here you can see, now here the distance in kilometer. So the intervals are 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25, 25 to 30, and 30 to 35. Okay, so now this is the maximum range, 30 to 35. Okay, so this is the range. Yeah, so now we have to telemark. So here how can, now we have to see the distance, the number of distance in 0 to 5. Okay, so here is, so here the upper limit, is not included. Okay, so we have to see the distance in the range of 0 to 5. Okay, but less than 5. Now let's see. So this is 3. Okay, and in the second row here, this is 2, this is 2, and the next one is yeah, this is 3, and this is also in the range of 0 to 5. Okay, and the next one is, yes, so how many? So 1, 2, 3, 4, 5. It means we can say that there are 5 engineers, which having the distance in the range of 0 to 5. Okay, yeah, so there are 5 total number of engineers. Now let's see the distance in the range of 5 to 10. Here is 5 is included, but 10 is not included. Okay, so now this one is 5. Okay, and 5 to 10, 10 is not included. Okay, this one, and here is, yeah, this one, this one, this one, this one. Okay, this one also, and the next one is, yeah, this one also, this one also, this one, this one. So how many numbers? 1, 2, and 3, 4, 5, 6, 7, 8. Here is 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 8, 9, 10, 11. So there are total 11 number of engineers. Okay, so how many engineers lie in the range of 5 to 10? There are total 11. Okay, now let's see the distance in the range of 10 to 15. Here is 10 is included, but 15 is not included. So here is 1 and 2, 3, 4. Again 5, 6, 7, 7, okay, yeah, 7, 8, okay, 15 is not included, okay, 8, 9, 10, and the last one is 11. So again there are total 11 number of engineers, okay. So here is, you can see there are 11 lines, like 1, 2, 3, 4, and the fifth one is cutting line, okay. 6, 7, 8, 9, and the 10 is this line, and the next one is 11. Now let's see the distance which lie between 15 to 20. Here is 20 is not included, here 15 is included. Now let's see, here you can see we are changing the color. So here is, now we have to see the distance in the range of, yes, 15 to 20, okay. 20 is not included. Here you can see, yeah, this is 19, okay, this is 1, 2, 3, 4, 5, okay, 6, 7, 8, 9. So there are total 9 number of engineers which having the distance between yes, 15 to 20, okay. This is, so similarly you can see now 20 to 25. Here you can see 20 to 25, there is just only 20, okay, and there is no another distance, so this is just only one. Now 25 to 30, here you can see there is just again similarly there is just one number, so again 25 to 30 there is just one. Yes. Now 30 to 35, here you can see 30 to 35. Now let's see 30 to 35. So this is 1, and the next one is, this is 32, okay. So there are two number of engineers which having the distance between 30 to 35, like this. I hope you understand this thing. Now if we total these numbers, so we get 40, and we have total 40 engineers in the question, okay. So this is the frequency distribution table. Here we take the intervals 0 to 5, 5 to 10, 10 to 15, and 15 to 20, 20 to 25, and so on, okay. I hope you understand these things. Now here if you see that, okay, so now if you observe this data, here the minimum distance is what? Here you can see the minimum distance is 2, and the maximum distance is 32. So here we can write, if you see that the minimum distance is 2, and here is maximum distance is what? This is 32. Now it can be observed that there are few engineers whose homes are at more than or equal to 20 kilometer distance from their workplace. Here you can see that after 20 kilometers there are few engineers, okay, and most of the engineers have their workplace at distance of 0 to 15 kilometers. Here you can see at the distance of, yes, 0 to 15 kilometers, okay. Most of the engineers have their workplace at the distance of 0 to 15 kilometer distance from their homes, okay. So this is the observations, okay. Yes. Now so the next question here is, the relative humidity in percent of a certain city for a month of 30 days was as follows. Here you can see this is what, this is the data of relative humidity which is in percent term, okay, for a month of 30 days. Here this is 98.1, 98.6, 99.2, and so on, okay. So first of all The question number 1 is construct a grouped frequency distribution. Here we have to construct a group frequency distribution table with classes like 84 to 86, 86 to 88. Here we have to take the class width as 2. Here you can see 84, this is the lower limit, and 86, this is the upper limit, and if you subtract upper limit minus lower limit, we get the class width. So this is what, this is 2. So similarly, and we have to take like this. Okay, here, so now let's construct it. Yes, so now here you can see that we are taking the intervals as 84 to 86, 86 to 88. Okay, so this is the class interval. Okay, this is what, this is relative humidity in percent. Okay, now let's do the tally. So we have to find the humidity between 84 to 86. Okay, here you can see in this data. Okay, so now here if you see, so there is just only one number 84.9 which lie between 84 to 86. Okay, so there are total number of days 1. Okay, so here is this column is what, this is of the column of frequency. Okay, and or we can say number of days. So they have one day which having the relative humidity in between 84 to 86. Now let's see the relative humidity in between 86 to 88. Okay, if you see this 86 to 88, okay, so there is just only one number, so we can say the number of day is just 1. Okay, which having the relative humidity in between 86 to 88. Okay, similarly there are just only two number which having the relative humidity between 88 to 90. Okay, similarly there are two number which having the relative humidity between 90 to 92. Okay, and so on and so on. So if we total these, if we do the total of these frequency, here we get 30, here we get 30, and we can see here is we are observing this data for 30 days. Okay, it means our table is what, our table is correct. I hope you understand these things. Yes, so now here is, now if you observe this in the data, the minimum relative humidity is what, this is, here you can see this is 84.9, and the maximum is what, and the maximum is, here you can see, if you see in this data, and the maximum is 99.2. okay, so here we can write minimum relative humidity is 84.9. okay, and maximum is what, and the maximum is 99.2. okay, yeah, so now let's move on. So here is, now which month or season do you think this data is about? So here you can see the relative humidity is high. It means the data is about a month of rainy season. Okay, so here we can write as, here we have high relative humidity. So relative humidity is high. Okay, so the data is about, a month of rainy season, okay, now what is the range of this data? So here we can find, so range is what, range of data is equals to, this is maximum value minus minimum value, this is maximum value minus minimum value. Okay, so this will be what, so this will be, we know that maximum is what, 99.2 minus minimum is 84.9. After solving this, here we get 14.3. What is? Yes, 14.3. So this is the range of this data. So how we can find the range of any of the data? We can, if we subtract maximum minus minimum, then we get the range of data. Got it? Yes. So the next question here is, now the heights of 50 students measured to the nearest centimeters have been found to be as follows. Here this is what? This is the height of 50 students, like 161, 150, 154. They are randomly. Okay. Now represent this data given above by a grouped frequency distribution. Here we have to represent in the grouped frequency distribution table. Now taking the class interval as 160 to 165, 165 to 170, and etc. Okay, got it? Okay, now here you see, this is the frequency distribution table. Here in this first column is of height, second column is of tally, and the third column is of frequency, like number of students. Okay, so here we are taking the intervals like 150 to 151, 155 to 160, 160 to 165, 165 to 170, and 170 to 175. Okay, got it? Now let's see, here is, now how many number of students lie in between 150 to 155. Okay, if you see in this figure, okay, so here we have to find 150 to 155. So there are total, if you observe this data, you get there are total 12 students. There are total 12 students. So if you do the telemarking like this, 1 2 3 4 5 6 7 8 9 10 11 12. So there are total 12 number of students lie between 150 to 155 centimeter height. Okay, now how many students lie between 155 to 160 160 centimeter height? Okay, so if you observe this, if you see this data, okay, if you see this observation, you will find that there are total 9 students. There are total 9 students. Okay, and how we can do the telemarking like this: 1 2 3 4 5 6 7 8 9. Got it? Similarly, how many students lie between 160 to 165 range? So if you see the again data, you will find there are total 14 students. There are total 14 students. Similarly, we can do the telemarking. Okay, and there are total 10 students lie between 165 to 170, and there are total 5 students lie between 170 to 175. I hope you understand these things, my dear friends. Okay, so by observing this data, now what is the minimum number? Means what is the minimum height in centimeter? Here you can see that 150 is the minimum. Okay, and what is the maximum? So if you observe this, the maximum is 173. So we can write here as minimum is, we can say minimum value is 150, and maximum value is 173. What is? Yes, 173. Okay, now what can you conclude about their height from the data? Now if you observe this, students shorter than 165, here is students shorter than 165 centimeters. So this will be how many students? You can see shorter than 165. There are 14, 9 and 12. Okay, now add these. If we add these, 12 plus 9 plus 14, here we get 35. It means out of 50 students, there are 35 number of students are there which having which having the height less than 165 centimeter. Okay, so it means what is the percentage? So we can find it by dividing like 35 divided by 50 into 100, we get 70%. It means we can say that it can be concluded that more than 50% of the students are shorter than 165 centimeters. So we can write, it can be concluded that more than 50% of the students are shorter than 165 centimeter. Okay, I hope my dear friend understand these things. Okay, so this is the frequency table, group frequency table and ungrouped frequency tables. Okay, I hope you understand these things. So we see in the from these questions how to make group distribution frequency table, okay, or ungrouped frequency distribution table. Okay, understand? So this is enough for today, and we will meet in the next lecture with the next amazing topic. Okay, so thank you very much for listening me, and take care and goodbye.